Today, I have a very special video. We're actually testing my automated bilge pump. This is the float switch that controls the bilge pump, and it's hooked up to a battery up here. So we will see if it works. It might not work. That bilge pump is pretty big, and I only have one MOSFET in there controlling it. I'm going to show you the circuit though. Here's the one we went with. So there's basically when there's no water, the switch is closed, and then when the water level raises the float switch up, it opens, and then the water drops and it closes. So there is a 50 kilo ohm parasitic drain, but if you had a 100 amp hour battery, that 50 kilo ohm resistor would discharge your 100 amp hour battery in like 47 years. So I mean, it's not too bad. But yeah, there's some hysteresis here. So when this opens, like this, the voltage here, which was 0, begins to charge up through this capacitor. So you've current flowing down like this. And so there it actually takes time. And then about 20 seconds after the float switch opens, this threshold voltage is met, which drives this MOSFET gate, basically drives it to the high rail, which makes it very conductive. So the circuit looked like that, and after about 20 seconds, you could think of it looking like that, right? So everything's connected. Can represent your MOSFET being on. It kind of looks like that. I mean, it's like 100 milliohms, but so now the water drops and we close the float switch. So now we were charging this capacitor up. This float switch pulls this point down to basically ground. So you can imagine there's a ground here. So that charged capacitor starts to discharge in an RC like time constant way. We take the R in ohms and the C in capacitance. So that's 4 divided by 1,000,000 times 500 times 1,000. That actually gives you the time in seconds it would take for the voltage at this point to drop to 62% or charge up to 62%. So tomato. Anyhow, eventually that threshold voltage is met again. It took about the same amount of time it took for the float switch to open, it closed. So now that threshold goes to 0, the MOSFET is now grounded, which will then make it look something like that, where there's just nothing there. Or, you disconnected the load. This is the load up here. There should be a resistor in here. I think that's actually, yeah, okay. So make that like 3 ohms or something. I don't know. Anyhow, that's kind of like a pump. And then I put a diode here for any back EMF weirdness. So I will let you know when the gate driver attempts to turn the MOSFET off and turn the pump off, when the pump is shut off, the rail voltage here bumps up, and for some reason there's some ringing that goes on as this MOSFET driver oscillates. It only happens for about a second, so it might explode. But let's see. I will tell you, this might fling itself out of this tub of water because this bilge pump is really powerful. So if it works, that should be interesting. All right, right now the float is in the down position. I'm going to turn it on. All right, now explosions. Now I'm going to push the float up. It's better not get me wet. Oh, slid down. Okay, I'm going to hold the thing up. Hold it up. Uh-oh. There's fire. Why does this always happen to me? Definitely a little warm. There's actually a lot of fire in here. Some smoking for the past minute. Something bad happened to something in here. I will figure it out. I think I popped that MOSFET down there. Yeah, I should have gone with a relay. Thought I'd be cool with a MOSFET. It's alright. This is only the second attempt. First attempt. So We will rebuild it and do better next time.